All right, guys, hello. So we're looking at 5.4 guided notes. We're going to talk about a couple different special ways of factoring, our standard old factoring, and then just going to learn how to solve today. So go ahead and make sure you have these perfect squares on the right side down. Oops, I'm drawing bonus lines here. Here we go. Look it over here. Make sure you write those down. Pause the video and go ahead and copy those perfect squares, or go ahead and put them in your calculator yourself, which you are absolutely very capable of doing. And let's jump in. So the first special form of factoring, which I know you guys have seen before, is called the difference of squares. And what that is two perfect squares that are being subtracted. So it's going to look like this. Some kind of a perfect square out here, x squared minus another perfect squared, another perfect square. And to solve, you're going to simply take the square root to factor. So something like this is going to break down into taking the square root of the first, and that goes into both first positions, and then taking the square root of the second, that goes into both second positions, 1 plus, 1 minus. So you're going to have the exact same factor, just 1 plus, 1 minus. So that's difference of squares. Then we jump into a perfect square trinomial. All right, so a perfect square trinomial is 3 terms based from the trinomial. And the first and the last have to be perfect squares. So this is how you're going to find that one. You're going to see a perfect square on the first, you're going to see a perfect square on the last, and we're going to just take the square root of those perfect squares, and then we can always just use B's sign for the middle. So whatever your middle number, your B value, we just pull that sign. So square root of the first goes into the first position, square root of the last goes into second position, and you always take B's sign. So it's going to either look like this, or it'll look like this if B has a positive number. So let's look at a couple of these. So here's some difference of squares. You can tell because there are 2 terms with a minus sign, an x squared and a constant, like we talked about above. So in order to solve this, we're going to have both of our factors set up. I know I'm going to have 1 plus, 1 minus, and all I'm going to do is square root it. So square root of 16x squared is 4x. You just take half of your exponent. So I'm going to have 4x in the first position, and then the square root of 49 is 7. So that's going to go into the second position on both. All right, and that is what our difference of squares is going to look like. So when I look over at this one, I see, again, an x squared with a perfect square and a perfect square. You can see them on your list on the right with a minus sign. If it's not a minus sign, you cannot do this. All right, so I'm going to take the square root here and get 11x in both first positions. And then I'm going to take the square root of 400, and I'm going to get 20 in both second positions, 1 plus, 1 minus. It does not matter which. All right, here's an example of a perfect square trinomial. And again, we can see this because the first term is perfect, the last term is perfect, and we've got our x squared, x, and a constant. So we are going to set this up here. And remember, the sign comes from B. So here's B. B is negative, so I know my sign's going to be negative in the middle, and we're always going to square it with our perfect square trinomial. So I'm going to take the square root of my first, which is 3x, and the square root of my last, which is 5, and boom, there's our perfect square trinomial. Can you do it the long way, the way that we've done in the past, and we multiply first and the last, and we find our middle term that's going to multiply to that number but get to the middle and split the middle? Absolutely, you can. It's just going to take a little bit longer, so why not find a shortcut if we have one, right? All right, again, I've got a perfect square up front, I've got a perfect square at the back, and then my sign for B is positive. So I'm going to set up my positive perfect square trinomial, and we'll take the square root of 16x squared to get 4x. and the square root of 1 to get 1, and there's my perfect square trinomial. Remember, guys, you can double check your work by multiplying it out. So if I do 4x plus 1 times 4x plus 1, and I distribute, I get 16x squared plus 4x plus 4x plus 1, and that'll simplify down to 16x squared. 4x and 4x get me 8x, and then 1. So remember, you can always distribute through and make sure you are right. All right, now we're going to do a little throwback to the good old factoring we know about. We can always factor with an x squared and an x in our terms. We can do the GCF, we can do the shortcut, and that's when we have x squared, some x, and a number. Or we can do split the middle. And that's when our x squared has a number out here that is not 1. Okay? So we're going to practice a couple of these. Make sure before you factor, always have it in standard form, which means that it's going to be set up x squared plus your x plus your constant equal to 0. So let's look at a couple of these. First things first, this is not in standard form, so I'm going to move both of these things over. So I'm going to have 4x squared. Anytime I move something across the equal sign, it just changes the sign. So 3x was positive. It's now going to be negative. 10 was positive. It's now going to be negative, equal to 0. This is a perfect square. So we've got a trinomial here, right? So I know I can't do the difference of squares because that needs 2 terms. I've got a trinomial. This is a perfect square, but this is not. So I can't use that shortcut of a perfect square. So I can't use my trinomial shortcut either because x squared is not 1. So this is where we do the split the middle that we just talked about. We're going to multiply the first and the last. So 4 times negative 10 is negative 40. So in order to multiply to a negative, I'm going to need 1 positive, 1 negative. And I need factors that are going to get me to negative 3. So 1 and 40, 2 and 20, 4 and 10, 5 and 8. All right, so those are all my factors. 1 and 40, in no way can they subtract or add to a negative 3. 2 and 20, same deal. 4 and 10, we're close. It can get us to a 6, but 5 and 8 can get us there. So I need to get to a negative 3, which means I've got to have my bigger number be negative. Negatives have to win here. So 5 minus 8 gets me to negative 3. So we're just going to replace that negative 3. So I'm going to keep my 4x squared, and instead of negative 3, I'm going to put plus 5x minus 8x. I got that from right here. And I'm making sure I tag them both up with an x because I'm replacing a like term of x. And then I can just keep bringing down the rest of it, so negative 10 equal to 0. And I can really truthfully forget about this equal to 0 for a second while I factor. So now that we're here, by the way, your 5x and your negative 8, they could go in any order. So now that we're here, remember we're going to split the middle and then we're going to factor. GCF, greatest common factor on the left and on the right. So yours might be a little different if you flipped the 5 and the negative 8. So the only thing that divides into 4 and 5 here is 1, but x squared and x, we can take out an x. So that leaves us with, after we divide, 4 divided by 1 is 4, x squared minus the x is x, plus 5 divided by 1 is 5, and x minus x, so we don't have anything else left here. We always drop the middle sign, and then between 8 and 10, our greatest common factor here is going to be 2, and I'll divide. Negative 8 divided by negative 2 is positive 4, x still stays put, negative 10 divided by negative 2 is positive 5. So remember, guys, remembering back to our factoring days, the goal is to get this factor to be the same and that can come down with us. And then our second factor is our outside greatest common factor, so 1x minus 2. All right, so we're still equal to 0. This is where we use our zero product property, which just means set each factor equal to 0. So you might be able to do this part in your head, and you might not. So first thing, we're going to subtract 5, so we get 4x equals negative 5, and then we divide by 4, so x equals negative 5 over 4. So when you do it in your head, remember you can go take the opposite and then divide. So I'm going to go negative 5 divided by 4, so I can already know that's going to be my finale down there. And then in the red, if I have 1x minus 2 equals 0, all I have to do is add the 2 to get my final answer of x equals 2. So there's a little split the middle practice for you guys. Watch that a couple times and make sure you're still okay with it. All right, on example 2, we are not in standard form, so we need to move everything over. I would go ahead and move this 5x squared over so that my x squareds stay positive. And then I'm going to subtract the 1 with its like term. So remember, we're just changing the sign if we're moving it. So now I have 6 minus 5 is 1x squared. 11 wasn't affected. And then 31 minus 1, positive 30, equal to 0. So this one has a as a 1. There isn't an additional number here, so we can do our shortcut. So remember, the shortcut is simply what multiplies to my last 30 that's going to get me to the middle of 11, positive. So 1 and 30 multiply, 2 and 15 multiply, 3 and 10, 5 and 6. So 1 and 30 cannot get me to a positive 11. Neither can 2 and 5. And remember, it's a positive 30 here that I need to multiply to. So I either need 2 positives or 2 negatives. And you know that they're going to be positives because they have to add up to a positive number. 3 plus 10 is 13. We're getting close. 5 and 6 get us to 11. So positive 5. Positive 6 get us to positive 11. We don't have to do the split the middle here because I know I can use my shortcut. So I can just bring in that positive 5 and bring in that positive 6. So remember, x squared and then 6x and 5x get me to 11x, and 5 times 6 get me to 30. And then I'll do my zero product property here where I set each equal to 0. Well, on this one, all I'm going to have to do is subtract 5, so I know x equals a negative 5. And this one I have to subtract 6, so x equals negative 6. So remember, on these, we're just taking the opposite sign. And our last little reminder on solving here is the square root method. The square root method happens when there's just a square root and a number, and we're just going to solve it like normal using all of our opposites. Don't forget, when I take the square root of a number, I always have a positive and a negative. All right, so let's look at a couple of these. I've got my x squared and a constant, so I'm just going to solve like normal. So I want to get x squared alone, then I'm going to get x alone. So I'm going to start with dividing 4, and then I'll have x squared equals negative 48. And if I want to undo a squared, I have to square root it. That's going to undo their opposite, which means I have to square root this. So that's going to tell us x is equal to a positive and a negative square root of negative 48. Well, we just practiced a couple lessons ago how to break that sucker down, so we're going to do it. So square root of 48 is going to break itself down into, we know the I is going to come out. And 48 will break down into the square root of 16 times the square root of 3. So that's going to get us x equals positive and negative. Square root of 16 is 4. We have that negative coming out to make an I. And then the square root of 3 cannot be simplified. All right, let's check out example 4. Again, guys, if you're like, what the heck just happened? Rewind back 35 seconds and watch me solve it 3 or 4 times, and then ask any questions that you guys have. All right, so we've got my variable squared and constants, so I need to set it up like this. So I have my squareds on one side and my constant on the other. So I'm going to move that 6 to the other side. We'll get 9m squared equals negative 20. Divide that by 9. And m squared equals negative 20 divided by 9. And then we square root to get rid of the squared. But we got a square root over here. So now we have m equals positive and negative square root of, and I can break it down into 2 separates, negative 20 divided by square root of 9. So we're just going to go ahead and simplify those square roots down. So square root of negative 20 is going to break into an I, a square root of 4, and a square root of 5. Because 4 times 5 is 20, and the I came from the negative. And on the bottom, we know the square root of 9. That is already perfect, which is awesome. So now we'll just reduce. Square root of 4 turns into a 2. The I then comes after the 2. And then the square root of 5 just tacks on at the end. All over the square root of 9 is 3. And then don't remember, please do remember. And then don't forget, because we took the square root of both sides, we have a positive and a negative. All right, guys. Hope that helped for today. Make sure to ask us all the questions you got, and good luck getting mathy.